Hi, hello, everybody. Let me open the presentation. Just a moment. Okay. So again, thanks to all of you to be in this webinar. Let's start by the webinar aims, okay? We are going to talk only about software functions, okay? As you probably know, there are a lot of tiny differences between LM1 and LM2, especially in the hardware side. But the aim of this webinar is just to talk about software functions, okay? So we are going to talk only about parameters and new functions included in LM2. As already introduced now, the functions included in LM2 that we're going to talk today are not included in LM1. Therefore, they are new functions. We are going to discuss, we are going to see which are the benefits of using those functions, which are the advantages we are bringing to you, we are bringing to the market when we use them. And of course, we are going to discuss a little bit about the parameters and which are the parameters related, and sometimes which is the recommended setting for those parameters, okay? So, webinar contents. In this webinar, we are going to speak about the functions listed here. First one, open loop control for synchronous motors, what we call as well sensorless control. Then rescue modes. As you know, in LM1, we have already rescue mode available. But in LM2, we have included two new ones, deliverance operation, which is an automatic rescue operation, and the rescue by gravity. We are going to tell you what's going on those new functions. Then travel direction change counter, which is one of the certified functions we have. Unlock safety gear function. Can open CIA 4117, or as known as well in the market, can open lift. Then we are going to launch here, we are going to introduce to you a new function we have developed here in Europe, which is a conversion tool to transfer parameters from LM1 to LM2. So through loader software, the LM1 loader software and LM2 loader software, an additional Excel tool, we can transfer parameters from LM1 to LM2 in case of retrofit. And the last function, vector control with peripheral PG, is one of the new functions included in LM2 that we have decided makes sense to make a specific webinar for it. So in this webinar, I'm not going to talk about this function, but next Friday in this week, we have a new session where we are going to speak monothematic about this function. So please, if you are interested on having some feedback about this function, or how it works, or where you can use it, join us next Friday. So now we are going to do a very basic poll, okay? Let me open it. This is just for us to have a feedback of the people who is attending. Sorry. Okay, so here you have, please select which is your position. So basically, we want to know if you have ever used LM1. So if you are already advanced user, okay, or if on the other hand you don't know our products and for you this is completely new topic, okay. So I see 12 people already answered. We're going to wait a few seconds more. Please, you need to click on the options. You have two options. Yeah. Okay. At the end of the questionnaire, I see still people is answering. Okay. Yeah, we have most of them advanced users, but some people who is not used to work with our inverters. Okay, I think I will stop now because we have waited already a bit. I see still people answering. Okay, it's fine. Thank you very much. So let's continue with the presentation. So here you have in this graphic very classical lift configuration nowadays. Okay, we have a lift shaft without machine room, with a synchronous motor, and with all the electronics either inside the shaft or on the door frame. Okay, from the architect's point of view, this kind of configuration is very nice. It's very optimized, but from the technician's point of view, it's a bit tricky because the access of all the components is not easy every time, and especially in case of failures, everything is not so easy. Okay. One big problem we can have in case of synchronous motors is that the encoder is broken, or either the encoder, the cable of the encoder, the board where the encoder is connected, so anything related to the feedback. Okay, and you will detect this because the inverter is tipping PG or ER4 or ER5. Okay, so in case of machine room, no problem. The technician go to the machine room and he can check, he can measure anything on the machine room, and everything is very, very easy. But in case of machine roomless, where the electronics are inside the shaft and we have no access, when the synchronous motor loses the feedback, so we have problems with encoder or cable or whatever, we cannot easily move the motor. And this is a big, big problem sometimes. Please keep in mind that this can happen in two situations. The first one is in case of standard usage, people traveling inside the lift, and the encoder breaks, so people is trapped inside the lift and we have to rescue them. But of course, this can happen during the lift installation when we are moving lift in maintenance because, I don't know, there was a problem with a cabling, somebody put the wrong cable in the wrong side, or the cable sent by the supplier is wrong, or the board is wrong, anything, and you have the lift stopped and cannot move because the encoder is not connected, okay? So this open loop control for synchronous motor is a new function that will help you to solve these situations because we can move the motor, we can move the lift, let's say, in open loop, so without the encoder. There are basically two parameters related to this function, L140 and L141. In L141, we enable the function. We enable the function by setting L141 to 1. This is a kind of protected function because, of course, we don't want to move the lift. We don't want to control the motor in open loop anytime. So we must ensure that the person who is doing this is aware of what he is doing. This is why when we change parameter L141, we don't change it just by up and down arrow, but we need to press a stop button, as you see in the image. Okay. And then we have the parameter L140, which is the current level at which we are going to control the motor. In other words, the value we specify in L140 is going to be the rated current of the motor during this movement. So how to adjust L141 parameter? Basically, we need to know which is the maximum current we are going to need in each movement. So for example, in case of driving condition, so car empty going down, for example, we are going to need, or we're going to have to set L141 to the maximum current that means the overload current during acceleration, as you can see in the graphic. This graphic, by the way, is taken with a lot of software. If you have difficulties to know how loader software works in case of real-time trace, so in this case of this graphic, we have used real-time trace. I would like to take this chance to let you know, if you don't know already, that we have a YouTube channel, and that in the YouTube channel we have some tutorials. And for example, in this case, we have a specific tutorial where we explain how to use the real-time trace function. So if you need some details about this, I would ask you to go to YouTube and check it by yourself. Then we have another option, no? So L141 in case of braking condition. In case of braking condition, the current we need to set in L141 will be the current where we have a constant speed, as you can see in the graphic. Okay. So basically, to adjust L141 parameter, we need to define the movement conditions. So what we are going to do, we are going to move in up direction, in down direction. We want to perform the rescue with full load or not full load. And we need to check the current, the maximum current under these conditions. The default setting of L141 is set to 80%. Okay, so basically is a good parameter, or the setting of L141 is okay, is correct in case of performing rescue of people in the braking direction, or in case of moving the lift during maintenance when the lift system is not finished. So when the counterweight is not loaded, when the car maybe is not finished. Okay, if you need to move the lift in a different conditions than I mentioned it now, you need to adjust the parameter L141, and you will have to basically increase, because under those conditions you will need more current. Okay. Finally, let me show you graphic of how the function will behave. Normally, you will move the lift in inspection. So you will put the lift in inspection mode. You will activate the parameter L141, as you can see on the graphic. So L141 parameter is set to 1. You press up or down button of inspection button. The controller will give run command. We will close the contactors. And after closing the contactors, the inverter is going to perform an automatic pole tuning, because we want to know where the magnet is placed. This, you don't need to care about anything. Everything is automatic. Okay. And after the pole tuning is finished, the brake will open and the lift will move normally with a standard speed profile that we are selecting by means of digital inputs or by means of communications. Okay. So I see no question so far. No. We have a question. So let me switch to question mode here. Just a second. Now. So we have a question, and is how I disable the function. Yeah, I was going to explain just this when the question arrived, because I forgot to mention. Basically, to disable this function, we have to switch off the inverter. In other words, we don't set the parameter 140 back to 0. Okay, because we understand this is a special movement, it's a rescue operation, or we are moving in maintenance. So in order to disable this function, we have to switch off the inverter, switch on, and when we switch on back, the control will be the previous one, so synchronous motor in closed loop. Okay? Okay. I see no more questions, so I will switch to the next topic. Okay, now we are going to have another poll. So now I want to ask you about rescue modes. So when there is a blackout on the main supply, which options do I have to rescue people? Can I supply the inverter by means of batteries? Or can I supply the lift controller by means of batteries? Can I use UPS? Or for example, can I do something more easy, which is opening the brake and controlling lift speed? Please select your options. I see already some people answered it. Okay, let's wait a bit more. By the moment, we have a winning answer, 10 answers, 11 answers. Almost half of the people have answered the question. Okay. Yeah, more than half of the people has answered it. So let me finish the voting here. Now I can share the result. Yeah, we have most of the people answering, all answers are correct. So in fact, all answers are correct. Okay, we can supply the lift system by means of batteries or UPS. Inverter is able to handle this condition, or we can do a more basic rescue operation by opening the brake and controlling the lift speed. Okay, good. So let's move to the presentation. Here. So in case of blackout, what happens? The mains is disconnected, and I don't have power supply on the system. I don't have supply. I don't have voltage intercurrent on the system. So what I can do is to supply the system by means of a UPS or batteries, as mentioned before. Okay, but in this point we always have the same questions: which is the best direction to perform the rescue? Is it better to go up? Is it better to go down? Well, this we will know it depending on the load I have inside the car. But do I know the load inside the car? How I can check the load inside the car? This is always the question we have when performing a rescue operation. Yeah. LM1 has the recommended running direction, which is working fine for synchronous motors. But in case of induction motors, especially in open loop, it's becoming more tricky because the torque is very constant. The torque at low speeds is not clear because of the gearbox if we are driving or braking. So it's not working 100% of the times. This is why we have included a new function in LM2, which is called deliverance operation. Basically, what we are doing is by monitoring the input power of the inverter, deciding if the rescue is being done in the right direction or not. So, in other words, the inverter will try to move the lift up direction, down direction. Inverter will check the input power. We will see if it's under a certain level, and if it's okay, then the inverter will perform the rescue. If not, the rescue operation will stop. Here you have the related parameters and the graphic of the movement. L123 is the parameter, is a byte parameter where bit by bit I can select, activate disable functions. Okay, bit 0 is the bit used to activate the function. So if we want to use the deliverance operation, we have to set bit 0 to 1. Then we have bit 2 and bit 3, which are used to decide what we are going to do in case that the power limit is reached. If I will stop right away, if I will try in the different direction, if I stop, if the limit is always reached, or if I will try to move anyway as the maximum speed I can move. There are different options. In the graphic, you see one of the most common situations and most common settings. Okay. So first of all, we have the battery signal, as you can see in the top of the graphic, coming from the controller. And then you see the controller is giving forward or reverse signal. Okay, it doesn't matter. The controller is asking the lift to move. The inverter will take this information as a start. Okay, and the inverter will always, as you see in the graphic on the lower part, F run, the inverter, will try to move always first in forward direction. As you see in the graphic, the lift starts to move, it accelerates, but during acceleration, after the timing L124, which is a filtering time, we reached the limit L122. So input power limit is reached, as you can see in the first part of the graphic. So the inverter understands that the UPS or the batteries are not sized for this rescue operation. So automatically, the inverter will stop the lift. And while the run command coming from the controller is still on, the inverter will try the opposite direction. In this case, reverse. Okay. We see that in reverse, it starts as well. The inverter accelerates the motor, and we don't reach, in this case, input power set in L122. As we don't reach this level, then the rescue operation will be performed, will be finished. Okay? And this is how the function is working. I see we have another question. Let me switch. Just a second. Let me switch to question mode. This I have to change. Okay. Let me publish the question. Here we have it. So we have one question which says, is this function working as well with a UPS? Yes, I think I mentioned it at the beginning. If I did not, sorry, this function is working for both, for batteries or for UPS. So in other words, it doesn't matter which kind of supply or alternative supply I'm using to perform the rescue operation. Basically, the inverter is checking the input power, and according to the limits and the parameters set on the function, the inverter will perform the rescue operation. So yes, with UPS is possible as well. Okay. I think that's all. Good. So let me go back to the presentation. Okay. Well, as we were explaining before, there is a third type of rescue operation, which is most basic, but as well useful, is the rescue operation by gravity. So basically, in this case, the question we make is what happens if the brake opens in the lift system. So here you have a very basic lift system with a motor, some pulleys, a counterweight of 500 kilograms, and a lift car with a very happy guy inside with a total load of 375 kilograms. In this case, what happens if the brake opens? If the brake opens, of course, the system will move in down direction because the counterweight is heavier than the car. And basically, this is the idea of this function. By means of digital input, with the function RB-RK, so rescue by brake control, we supply the control board of the inverter by means of 24 volts, and then we have power enough on the inverter to open and close the relay, which is controlling the brake. And we will open and close the brake, or the inverter will open and close the brake, making the lift system to move in the low direction. In this case, in this example, in down direction. So here we have a graphic of the movement, rescue by gravity. In this case, we will have the signal coming from the inverter, from the controller, RB-RK. You see it's on all the time. So in this moment, when the inverter received this signal, the inverter will open the brake. So you see BRKS going to on. And we understand that slowly the system will start to move in down direction. It can be the case that the speed limit set in the parameter 117 is never reached. In this case, the lift will move at a certain speed and always under parameter 117 until a certain point where the controller stops because we have reached the floor level. So the controller removes the air rescue by gravity signal, and the inverter will stop. Okay, will stop means will stop controlling the brake. The other case, or the other option is that we reach the L117 speed limit. This means that the lift is moving too fast under this gravity condition. What the inverter is going to do in order to keep the lift speed under a certain safety level, the inverter will close the brake, will wait a certain time until the mechanics are settled, and will open the brake again. So the inverter will do this movement of opening and closing the brake until, again, we have reached the floor level. So basically, this is how this function is working. Okay, I see we have another question. Let me move to the question mode. Let me publish the question. Here we have, how does the inverter knows that the floor level is reached? Basically, the inverter doesn't know. The inverter is controlling the speed or monitoring the speed, because we have an encoder. We understand we have an encoder in this movement. So the inverter is permanently monitoring the speed. So we know if the lift is moving and at which speed. But we don't know if we have reached the floor level, because the inverter has no information about the shaft or the positioning. This information will come from the controller. So it's the controller the one who is monitoring if we have reached the floor level. When we have reached the floor level, the controller will remove the digital signal, the digital input from the inverter, and we'll set the function to off. So by removing the input, but the digital input, the function will be off, and then it's understood that we have reached the floor level. Okay, good. So let's move to the next one. Next topic is about suspension means. Yeah, in this image you see the very standard or most used suspension means in case of electric lifts. First one is the standard metallic ropes. Yeah. Second one is coated ropes. So metallic ropes plus a plastic cover. And finally, we have the belts. Yeah. This means different cores of metallic rope together linked by a plastic, which makes a kind of belt. Yeah. Probably all of you have seen this kind of suspension means in the lift system. Okay. At this point, let me make another poll. No, sorry, here. This one. So, suspension means of coated ropes and belts. According to the EN 81-20 or -50, can we use them? This is a question with a bit of tricky answer. First answer is yes. Yes, we can use ropes, coated ropes or belts, because they are accepted in lift standard EN 81-20-50. Second, no, it's not allowed according to the standard. Third, yes, if I follow certain rules, or no, it's not allowed by the standard, but I can do something. Okay, some people already answering. Let's wait a bit. Good. More or less half of the people answered it as well. We have, again, a winning option. Let's wait a bit more. Okay, I think it's enough. So let me finish the voting. Let me show the result. So most of the people have answered it at the last option, the tricky one, which says yes if or no but. Okay, yeah, probably this is the most correct answer. Let me go back to the presentation. Yeah. Let me share the screen, just a moment. I think you cannot see my screen at the moment. Let me start again, sorry. Okay, I think now you will see. Now, good, sorry. Always technical problems when we are doing lives. So Well, answering basically the question I did was not 100% correct because, okay, EN81-20-50 does not speak especially about coated ropes or belts. It's not mentioned anywhere on the standard. But basically, the standard speaks about a safety factor. So the suspension means needs to fulfill a certain safety factor. Yeah. The reality is that this safety factor is very difficult to be reached, as it is described in the standard, for belts or coated ropes. Okay. So how do we do this, or how the companies which are doing those suspension means solve this problem? Basically by using a type examination certificate. Type examination certificate is a certificate where notification body specifies under which conditions the suspension means can be used. And if these conditions are fulfilled, as a notification body certifying that the suspension means is correct, then it can be used. Yeah. And in case of belts or in case of belts or coated ropes, basically what we need to ensure is that they are okay. By okay means like you see on the picture, some metallic parts broken. Yeah, we need a number of direction changes, which is basically the movement which makes the rope to suffer. We need a number which says, okay, below this number, the suspension means will work fine for sure. We guarantee this. Above this number, we don't know. So the best of you must change the suspension means. Okay. And basically, this is the function which has our inverter. We have a counter which counts the direction changes. So every time that the lift moves from up to down, we are counting this. And when we reach a certain number, which is given by the suspension means manufacturer, we stop the lift, we trip an alarm, and well, we push the end user to change the suspension means. Yeah. How this function is working. So first we have passwords, as is a safety function, is another function certified by the notification body we have in LM2. First, we need to set a password, so only the right technicians will be able to start this function and to modify this function if it's needed. And this password will need to be introduced in the inverter every time we need to do a change. Okay, so like this, the function keeps blocked and only can be used by the appropriate technicians. So how this works. So for example, here in this graphic, we have a lift movement. You see the speed is going up, stopping, going up, stopping until this moment. Fine, nothing happens. On the next movement, we go down. We go down 2 times. So this means we have one direction change. So we have an internal counter, which is L113, which counts. You see, the L113 has changed from 0 to 1. Good. At the same time, we are comparing if this number is same or has reached the limit L111. Yeah, on L111, we are going to set the value given by the suspension means manufacturer. So the maximum allowed movement of direction change. Okay, we have not reached, so this is fine. Next movement, we go up again, so we have a new direction change. So the counter L113 increases the number on 1, so we have 2 direction changes. And finally, we have a third direction change. So 113 equals 3. We reach the level 111. So this means from this point, the suspension means it's okay anymore to be used, so we have to change them. And you see, as you can see on the graphic, even the controller starts or asks the lift to move, the inverter will not react. The inverter will trip an alarm, and this alarm will block the inverter until, by means of introducing the password and by means of doing a certain procedure, we change the belt and then the coated ropes, and then we can start the lift again. Yeah, there is a way to move the lift even it's blocked by this alarm, and this is by switching off and on the power supply of the inverter. Okay, so every time we switch off and on the power supply of the inverter, we are allowed to do 1 additional movement. Yeah, after this movement, again, the lift will be blocked. We have a warning message. Yeah, we have a warning message that can be adjusted on the inverter in order to prevent the workers or the lift maintenance people that the limit is almost close. Yeah, so you can adjust this parameter to inform, I don't know, some weeks before, some days before, that this is going to happen. And then on the keypad, you will see a flashing signal saying, warning, you are almost reaching the limit. Yeah. And finally, this function is linked to the parameter, to the keypad, sorry, TPA1LM2. Why this? First one, because in TPA1LM2, we can monitor warning alarms, yeah, or warning messages. And second, because we have a second counter on the keypad. Why we have this? Because it can happen that the inverter is broken. Yeah, for any reason, the CPU goes out of order. So what would happen in this case? Would happen that the counter L113 is gone. So that we don't know which is the usage of the suspension means. Yeah. In this case, what we have to do? Well, we have to change the belt or coated drop, but thanks to the keypad that is counting as well. So we are keeping double counting. This is not a problem. In case of the inverter is broken, no problem. We put a new inverter, and from the keypad we download the parameters. Okay, so the lift can continue how it was before. Okay, so that's all about the travel change direction function. I see no questions so far about this function. So let's move forward. Yeah. Next function is a unlock safety gear function. Yeah, here we have the same kind of lift. You know that in the lift we have the safety gear, which is monitoring all the time the lift speed. And if the lift speed goes above the safety level, there will a speed governor acts, and then we block the lift mechanically. Yeah, this is always a tough situation because we have a lift mechanically locked and we have to unlock it. Yeah, normally we need mechanical tools to do this. But why not using the inverter overload, which of course is available, to unlock the parachute? Yeah, we can try to do this always in the opposite direction where the parachute has been locked. So if the parachute has been locked moving in up direction, if we move the lift in down direction, we can, by means of the overload of the inverter, we can try to unlock the speed governor. Yeah. How this function is working, you have two ways of activating this function, either by parameter L101, so it would be a kind of auto-tuning or pole tuning. By the way, going back to YouTube, we have as well a tutorial how to perform a pole tuning that I invite you to check. It's a very nice one. So with the parameter L101, we can activate from 0 to 1 this function, or by means of digital input as well. We can set a digital input on the inverter, and by means of activating the digital input, this function will be activated. And how this function works, very basic concept. So we set a torque level or a current level in L102, and the inverter is going to generate a certain number of pulses of this torque or current pulse. And we set this number of attempts in the parameter 115. Okay, so imagine in 102 we set 180% of overload allowed, and in 105 we set 3. This means that the inverter will apply 180% of the torque or current during 3 times during the time specified in parameter L103. Yeah, and by means of these shocks, the inverter will try to unlock the lift. In this system, you see that on the first attempt, nothing is happening. On the second one, the lift starts to move. Yeah, and on the third one, the lift is finally unlocked. You see it because the lift speed increases fast. Yeah, as you see here on the parameter L106. We have a speed limit, so we want to avoid that that the lift goes uncontrolled with a very fast speed, and of course, we would lock the safety gear again. So we will control always, we will monitor always the speed, and we will keep the lift speed under L106 level. Yeah. Another important point is that as you see here, we have set in this function, in this example, 3 times of trials. If on the first one, we already see that the lift is completely unlocked, and completely unlocked means that we have reached the speed limit, then we cancel the operation, because we understand it doesn't make sense to try again when the lift is moving free. Okay, good. So that's all. Let's move to the next function. Actually, this is a function that could create a new webinar, because it's a very extended function. There are a lot of options to do. We just want to describe it very briefly, and well, we have the manual of this function, which is CanOpen CIA 417, on our webpage. You can check it. If you're interested, please contact us. And if we think makes sense to make a webinar for this, we will consider, why not. So yes, as mentioned, Phrenic Lift LM2 includes CanOpen Lift, so CIA 417. Now, we activate this function by the means of the parameter y33 equal to 2. Yeah. The idea is of this CanOpen profile is that is a CanOpen profile defined by CIA, specific for Lift. And actually, Fuji Electric is one of the members who is attending to the meetings and helping to write down this standard. So basically, as you can see here, we have a specific PDOs dedicated for lifts. So we are not working anymore with PDO 1, PDO 2, or PDO 3, as you probably know from the LM1 and the CIA 402. But we have a specific PDOs. Here you have some examples, the PDO, write PDO, in this case, a PDO sent from the controller to the inverter. So RPDO 259 or RPDO 261, where we send the control word, mode of operation, which means position mode or velocity mode, which is the target velocity, which is the target position. Yeah, so as I already mentioned it now, as I have already introduced now, under the CIA 417, we can do positioning. By positioning, we understand that the lift controller sends a target position into the inverter, and the inverter generates the speed profile to reach this target position. So you don't need to care about the acceleration, deceleration, magnets, and so on, because the inverter, by the command sent from the controller and by an absolute encoder, will position the lift in the target position. Yeah, of course, another option is to do a speed control, which is just a lift controller sending target speeds into the inverter. But this is something known, and this is something you do already with the digital inputs with the standard controllers. Okay, and then finally we have a state machine adapted to the lift movements. Yeah, so the state machine, as we know in CanOpen, we have the state machine, which is specifying different movements or how to activate or stop the inverter. In this case, all the steps in the state machine are linked to the lift. So closing the contactors, opening, closing the brake, respecting the times, to control the rollback, to stop and close the brake. So all the standard lift movements, all the things you have to keep in mind in standard lift movement are taken in consideration in the state machine. Okay. Good. I see no questions so far, so let me continue, but please feel free to make any question if you feel like. And the last function we are going to speak today is the parameters conversion tool for loader. Okay, as mentioned before, here in Europe we have developed an Excel tool which convert CSV files generated by loader software from LM1 to LM2. So how this is going to work? We have a Phrenic loader for lift, LM1S. We connect computers, we connect Phrenic loader to the inverter, to LM1, and then we upload the parameters into the loader. When the parameters are uploaded, we save these parameters into the CSV file. And if you don't know, when you save parameters on loader software, you can choose if you save it in the standard loader software format, which is FNC, depending on the loader software, or in CSV. So in this case, we will save it in CSV. Then you go to the tool, this tool that we have developed here in Europe, and this tool is going to take the CSV file from LM1 and convert it, adapt it to a new CSV that can be used in the loader software for LM2. Yeah, loader software for LM2 is Phrenic Loader 4. Phrenic Loader 4 is a global loader software where we can use LM2, but we can use as well ACE, Mega, and all the new generations. So from Phrenic Loader, we open the CSV file and we import it, yeah, and we convert it. And when it's converted, we can download it to LM2. Okay, so thanks to this tool, we can make the retrofit of old or broken LM1 to LM2 very, very easy. Okay, so that's all. By the moment, so my presentation is finished. I hope you have enjoyed the presentation. That's all for today. In case of technical questions, we have a specific email, which is technical.inverters@fujielectric-europe.com. Please use this inverter in case you have this email, sorry. If you have any question, feel free to send an email, and any person, either myself or my colleagues from the technical department, will answer your questions as soon as possible. Okay. So now it's another open time for questions. Okay. Let me check if we have some questions. Yeah. Let's move here. Question mode. Good. So here, where I can get the conversion tool, can I find it in the website? Not yet. Okay, it's not yet uploaded on the website, as I mentioned it. It's a very fresh tool, and well, we have created it those days, and well, it's not yet uploaded. The idea is to upload it, but please contact us by email, and we can share it to you. We have the manual, we have the tool, and yeah, please contact us by email, and we will send it. And we hope you can enjoy this tool.